Hi students, welcome to the session. I am Dr.K.Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In this class, we are going to learn about bubble sort algorithm. Overview of the session. First we see what is sorting. So after that we see the definition of bubble sort. After that we discuss about bubble sort algorithm and time complexity of bubble sort, and finally we discuss about advantages and disadvantages of bubble sort. Outcome of this lecture: at the end of this lecture you all are apply bubble sort algorithm to sort elements in a list. So what is sorting? Sorting is the process of arranging a collection of items or elements in a specific order, so typically based on some criteria, so maybe ascending order or descending order. Now, so what is sorting? So sorting is nothing but arranging the elements. Okay, the goal of sorting is to organize the elements in a way that makes it easier to search for specific items, retrieve information efficiently. So for example, in linear search, to find an element is difficult. It took more time to retrieve an element from the array. But coming to binary search, in binary search the time complexity is reduced when comparing to linear search. The number of comparisons are reduced in binary search. Why? The main reason is in binary search the elements are in sorted order, but in linear search the elements are not organized. But in linear search the elements are organized in the form of ascending order. So it is very easy to search a particular element in binary search. Okay, I hope you all understand what is sorting and what is importance of sorting. So sorting means arranging the elements, and why it is important? If you arrange the elements in any order, then it is very easy to retrieve. So the basic sorting technique is bubble sort. Bubble sort is a simple sorting algorithm that repeatedly steps through the list of elements to be sorted, compares each pair of adjacent items and swaps them if they are in the wrong order. So let us consider 6 elements: 0, 1, 2, 3, 4, 5. This is the array name A. So let us assume these are the elements 15, 9, 18, 45, 98, 35. Now what is bubble sort? So bubble sort compares each pair of adjacent items. Now I compare these two, 15, 9. 15 is greater than 9, so swap. So now it becomes 9, 15, 18, 45, 98, 35. Now again I compare 15 with 18. So 15 is greater than 18? No. So in next iteration I compare 18 with 45. 18 is greater than 45? No. So no swap. Next I compare 45 with 98. So 45 is greater than 98? No. So in next iteration I compare 98 with 35. So 98 is greater than 35? Yes, it is greater than 35. So swap. So it becomes as 9, 15, 18, 45, 35, 98 if you swap these two. Now this is the result after first iteration. In bubble sort, in first iteration we found the maximum number present in the array. So what is the maximum number here in this array? 98. So 98 is stored as the last element in the array. Okay. In next iteration we follow the same procedure. We are going to compare adjacent items. If it is greater, then swap. This is the simple algorithm. It is named bubble sort because smaller elements bubble to the top of the list. So top means 0th location, we store the small values. Okay, at the end of this bubble sort algorithm, what is the expected output? 9, 15, 18, 35, 45, 98. Now bubble sort means the small elements 9, 15, 18, 35, 45, 98. The small elements bubble to the top of the list. Now this is the starting. So this sorting technique we called as bubble sort. So now we see the algorithm. So let us assume, so this is the ARR. Let us consider 6 elements 5, 2, 1, 18, 12, 13. Okay, so now we start from, now this is the ARR, n equals to size. What is the n here? In this case 0, 1, 2, 3, 4, 5, the size is 6, n equals to 6 now. Input ARR is the array to be sorted, n is the number of elements in ARR, so n equals to 6. Output ARR is sorted in non-decreasing order. That means at the end of this algorithm, it changes like 1, 2, 5, 12, 13, 18. Okay. Now we take one temporary variable. This variable we use to swap the elements. We start from I, from 0 to n minus 2. So what is the n here? N is 6, 6 minus 2 means 4. That means we enter into this loop 4 times. Okay. In first iteration, what is I value? I equals to 0. And j from 0 to n minus 2 minus I, each iteration we find the largest value. So the comparison is reduced by 1. So it is I value. So 0 to n minus 2. So 4, 0 to 4 in this case. Now what is I value? 0. So it is starts from 0, 0 to 4. So here we compare adjacent elements. So ARR of j. What is ARR of j? 5 greater than j plus 1, that is 2. 2 greater than 5 greater than 2, it is true. So swap. These 3 instructions is for swap. If we swap, it becomes as 2, 5, 1, 18, 12, 13. In next iteration, j value becomes as 1 now. Error of 1, 5. You compare 5, 1, 1. Yes, 5 greater than 1. So again swap 2, 1, 5, 18, 12, 13. Next iteration compare, so 5 with 18. No, 5 not greater than 18. In next iteration j plus plus, now 18, 12. Yes, 18 is greater than 12. So it is 2, 1, 5, 12, 18, 13. In next iteration you compare 18 with 13. Yes, 18 is greater. So swap 2, 1, 5, 12, 13, 18. So this is the resultant array after first iteration. Okay, here in this case j value becomes 5, 5 less than 4 will be false here. Then again control moves to outer for loop. What is the outer for loop? I from 0 to n minus 1. Now I value will be incremented by 1. So now I equals to 1 now. Again we enter into the loop. Again j value equals to 0. Now n minus 2 minus 1 means 3 now. 0 to 3. 0, 1, 2, 3, 4, 5. Now again you compare 2, 1. So 2 is greater than 1. So swap. So 1, 2, 5, 12, 13, 18. Next again 2 compare with 5. So 2 is smaller than 5. So no swap. Again compare 5 with 12. So 5 is not greater than 12. So no swap. Again compare 12 with 13. Yes, 12 not greater than 13. So no swap. Okay. Again j value becomes as 4. 4 less than 4 is false. Then again the I value become 2 now. I equals to 2 now. Now this is the resultant matrix after second iteration. Again you apply. Check 1 greater than 2. No. So 2 greater than 5. No. 5 greater than 12. No. Now the condition will fail. And again I value become as a 3 now. Again you compare error of j greater than error of j plus 1, false. Next 2 greater than 5, false. Now again last iteration we compare only 1 and 2. Now so this is the resultant array. So 1, 2, 5, 12, 13, 18. Okay. So this is the algorithm, simple algorithm. In bubble sort we compare only adjacent items, adjacent elements. Okay. So coming to time complexity. So bubble sort in the worst case and average case scenario, bubble sort has a time complexity of big O of n square. So why, how many loops we have? 2 loops. One is outer for loop, another one is inner for loop. So it is big O of n square. So where n is the number of elements in the array. In best case scenario, the time complexity is big O of n. The best case is nothing but if we give the elements in sorted order. For example, if I give 1, 5, 15, 18, 20. So this as a input, then no need of swapping. So the time complexity will reduce it to big O of n in this case. So this is the best case. In average case and the worst case, the time complexity is big O of n square. That is a disadvantage of bubble sort. So advantage and disadvantage. Advantage is simple and easy to implement and no additional memory requirement for bubble sort. Within the array only we are going to swap by taking one temporary variable. So coming to disadvantages, inefficiency for large data sets. If the elements are 10 or 15 or 100, then we can use bubble sort. If the data set is huge, then the bubble sort is not efficient for sorting and not suitable for real world applications. Why? In real world we can handle huge amount of data. So it is very difficult to handle. So bubble sort is not suitable for real world applications. So coming to summary of the session. In this session we discussed about bubble sort algorithm. So bubble sort is easy to understand and implement. In bubble sort we compare adjacent elements. So bubble sort is easy to understand and implement. Its inefficiency for larger data sets makes it less practical for real world applications. I hope you all are understand bubble sort algorithm. In next class we are going to learn about implementation of bubble sort in C programming. If you have any doubts, so place your doubts in the comment section. I will answer all your comments. Thank you.